Right, I'm on a roll, so I'm going to keep going. The next question in Sierpinski's book is prove that 19 divides 2 to the 2 to the 6k plus 2 plus 3 for k a non-negative integer. So presumably the base case is fine. The base case k equals 0, 2 to the 2 squared is 4, 2 to the 4 is 16, yes, it's 19, and 19 divides 19. What about the inductive step? So this is different to the last one, isn't it? Because there's a double exponential involved. So I'm not going to write down the solution yet. So here are some thoughts. If AK is 2 to the 2 to the 6k plus 2, I want to do it by induction, of course. Then what's AK plus 1? It's 2 to the 2 to the 6k plus 8, and so that's 2 to the 6 times 2 to the 6k plus 2, and that's a to the power of b times c. Aha. And so it is, I think it's a of k to the power of 2 to the, what's 2 to the 6? 64, right? I think AK plus 1 is AK to the 64. And so you can lean do 16 to the power 64. Yes, it can. So what's the remainder when we divide that by 19? Can it do that? Yes, it can. Right, so this is... So if we could prove that, so I should say that just because Lean can evaluate that doesn't mean that we're going to be able to prove it. If we can do this, then we're done, because all of the AKs are going to be congruent to 16. Oh, this percentage sign means modulus. You see, it's called hasmod.mod. It's notation for mod. So, okay. So note that 16 to the power 64 is 16 mod 19, according to a brute force calculation. And so all of the AK is 16 mod 64. Sorry, 16 mod 19, and we're done. I wonder if we can prove that though. So let's see if we can do it. So lemma 16 power 64. Oh, you can't begin with a number, I think. 16 power 64 mod 19. My claim is that... What is the best way to say this? Do you know what? We haven't done any... We've done everything with divisibility. We've never used mod 19. I wonder if I can do this. 16 mod 19. Oh. 16 in z mod 19. Right, I'm going to import something. So import, what will it be? Data.zmod, is that a thing? .basic. There's a guess. Restart Lean, see what it thinks of that. Oh, it's bought it. 16 to the power 64 equals 16. Colon equals begin, end. Now what? Nothing. So that is REFL. Yeah, this might time out. Oh, whoa. It hasn't timed out. Does normnum? Oh, normnum fails. Yeah, that takes some time, but it does do it. So that's good. So if we can do that. Do you know what? I'm going to put a little full stop there, which means don't evaluate it anymore. Right, so let's do it. Example, k is a natural number. I claim that 19 divides 2 to the 2 to the 6 times k plus 2 plus 3. Oh, what have I done? There. Begin. Right, I think if it can do that, then we should be able to do this by induction. Induction k with DHD, and the base case should be norm num. Actually, the base, it might be REFL. Does REFL work? Yeah, REFL. REFL works because the right hand side is 19, and so 19 divides 19. Divisibility is reflexive. Now, how are we going to do this? So let's try and use the Z mod. Well, for a start, I need to do the calculation which I was doing. That I need to do this, right? Let's copy this. So we have H. That thing there equals this thing here. Copy. Equals this thing here to the power 64. And does ring exp do this? Oh, it does. Look at that. Yeah, it's done it. Ring exp is a version of the ring tactic which knows about exponentials. So that's good. And now I wonder, so if we can turn this into a question about Z mod 19. Right, so let's press on then. Have H1. I wonder if I can do... Oh, don't you hate it when Lean does that? You have to... Yeah, let's pin it. Have H1. Oh, where's my pin? Oh, there's my pin. Huh. Oh. No, hard luck. I want to get this working. Let's unpin it then. Let's pause it instead. Oh, that's worked. Have H1. I claim that this thing here in Z mod 19. What if that's going to work? I want Lean to work that out as a natural number. And then when it's finished doing that, I want it to reduce it mod 19. Z mod 19 equals 0. And I wonder if I can do library search on that. Because I know 19 divides it. It's not looking good, is it? It's not looking good at all, in fact. Oh, I tell a lie. There we go. Z mod nat coe Z mod x0 if devud. Yeah, that's exactly what I wanted. So in fact, I could just rewrite that. Because we probably don't need H anymore. So I could rewrite left this thing here at H. How about that? Oh, it didn't work. What do I do? Oh, at the wrong place. That's the problem. I want to rewrite it at HD. Are we now back? I I'm completely confused. Why isn't that O? Because what do I have to do? Stupid thing. Right. Yeah, there you go. Great. HD says that is 0 mod 19. And so now I want to deduce that this thing here is 0 mod 19. So, do you know what? Maybe that's the H2. I want this thing here, that natural number there. I want you to compute this in the natural numbers, please, Lean, because that's where we're working. And then when you've done all the... What I'm worried about is if I coerce it straight into Z mod 19, then it will imagine it's sort of 2 in Z mod 19, and then I'll have to sort of fight there. So why is this 0? And the reason that's 0 is that I've already proved I can rewrite H, and now, and now I know, oh, this isn't even true. This isn't even true. I want this to be, this is 16, right? Yeah, I've never done that, have I? HD says that this thing is right. So now I wonder whether I know I want to. I could, okay, I could rewrite this at HD and at the goal there, and now I need to, I wonder if I can get away with not doing any more halves at all. I want to say that the coercion of A plus B is the coercion of A plus the coercion of B, and that's probably called nat.cast_add or something. Yeah, that's worked. And now I can rewrite H there, and now I can the point is that HD tells me that this thing is 16, so I need to rewrite nat_cast_add at HD. As well. So now instead of saying plus 3 equals 0, I really want to move that 3 onto the right hand side. And then I'm going to use this, and then I'm going to use my lemma. Okay, so how do I deduce? How I need to go from A plus B is 0 to A equals minus B. So I wonder what that's called. So example, so A and B in Z mod 19, and then a hypothesis that A plus B is 0. And I want to deduce that A equals minus B. And what will that be called? Something nice. Ec neg of add or something. Oh, it's having a good think. Why is it thinking so much nowadays? It's because I've imported. Maybe data.zmod.basic. Oh, here we go. Ec neg of add x0. And is that a, oh, that's not an if and only. Oh, that's a blow. Because I'm going to need it both ways. Can I do if and only if? Silly me. Alright, hang on. Cat wants to come in. Let's get the syntax right, and then I'll start live research off and let the cat in. Yeah, coming. Yeah, it's finished already. Ugh. Hello. Right, so I probably want to rewrite both of these things here as well. Can I just do all of this in one go? This thing here, nat.cast add, and this thing here. Right, great. And now rewrite H. And so now I'm claiming... now I can rewrite HD, right? Rewrite HD and H. Oh, what have I done? Found something silly. Oh, I've never rewritten HD. So I rewrite H. There we are. And now I need to move the arrow. I'm taking a natural power. This up arrow means reduce mod 19, right? I'm taking a natural power and then reducing, and I want to... So this is presumably nat.cast pow or something. Rewrite nat.cast pow. It was. And now I can probably rewrite HD. Yeah, exactly. You're going out. I'm not letting you back in again. There, and now my claim is that this is... and now my claim is that this is this. Convert this. See what? Oh, there we go. That works. That's great. So that's it. Excellent. That's that entire question's done. Yeah, these are somehow, in some sense, these are fiddlier than I'd like, but I mean, I guess over the years I've picked up some tricks. Right, let's press on to the next one. Thanks for watching.